Assalamu alaikum and welcome to Cambridge Chemistry channel with Sarwat Ahmed. Be sure to like the video and subscribe. It really helps the channel to grow. Today I will discuss the calculation of titration questions of paper 3. This is paper 9701 May June 33 May June 15 paper 3. So students, uh, I will discuss the calculation by using these readings. These are the supposed readings, and you are using your own reading which you have observed or which you have recorded during the experiment. So let's start. HA is an organic acid. Solution FA1 was prepared by dissolving 13.1 gram of solid AJ in each dm cube of the solution. You are to determine the relative molecular mass uh, MR of AJ by titration with aqueous sodium hydroxide. So the equation for the reaction between HA and sodium hydroxide is given below. This is the reaction for this chemical reaction which is taking place in the uh, reaction which is taking place by using titration. You know that HA, this is very important to understand the summary of the question. The concentration of HA is given in 13.1 gram per decimeter cube, and this is solution Fa, and Fa2 is sodium hydroxide. The concentration of this solution is 0.100 mole per dm cube aqueous sodium hydroxide. Now follow the instruction of the method carefully, and in method fill the burette with Fa1. Like Fa1 is HA and you have to fill Fa1 in the burette. Use the pipette to transfer 25 centimeter cube of Fa2 into the conical flask. This is Fa2, which is sodium hydroxide, whose concentration is 0.100, and it is taken 25 centimeter cube of this solution is taken in flask with the help of pipette. Add a few drops of bromothymol. Bromothymol is an indicator which is used to identify the end point of this titration. This indicator is blue in alkali. He has given the color of the indicator that it is blue in alkali and yellow in acid solution. It means in flask the solution is turns blue when you add bromothymol, and when it titrate against HA acid it turns yellow. It means yellow is end point of this titration. Now perform through titration and record your burette readings in the space below. So just draw the table for rough titration, and for rough titration first column is of final burette reading, second is initial burette reading, and third is volume of Fa1 is used. So this is let's suppose that 25.60 is my final reading and initial reading was 0.10, and the difference between these two reading is 25.50. It means 25.50 volume is used to neutralize alkali. The rough titer is 25.50 centimeter cube. So carry out as many accurate titration as you think necessary to obtain consistent results make certain any recorded results show the precision of your practical work. Record in the submit. Again, draw another table for the other three readings. So the same headings are there as you have drawn for rough titration. Final burette reading, then initial burette reading, and volume of FA1 is used. So this is the first titration. Final reading is 25.30, 0.10 is 25.40, 10.00, 25.40. So this is the third titration accordingly. So by subtracting initial reading from final reading, we get these titration results. Now select the best titration. The first choose the smallest value or the reading which have difference 0.2 centimeter cube. Select two readings which have difference 0.2 centimeter cube. So I have 25.20 and 25.10. These are my best titrations. Now next question, from your accurate titration results obtain a suitable value to be used in your calculations. Show you clearly how you obtain this value. So just show this calculation. This is very important. For this, just don't calculate this only on the calculator. Just show your calculation, because he asked you that from your accurate titration results obtain a suitable value to be used in your calculations. Show clearly mean he asked to show your calculation. So this is how to calculate average reading. You know it very well. 25.20 plus 25, two best iterations add and then divided by 2. So in this way we get best volume result, accurate volume of the FA1 used in titration. 25 centimeter cube of FA2 required. It means FA2 required 25.15 centimeter cube of FA1. Now start calculation. Show your working and appropriate significant figures in the final answer to each step of your calculations. Calculate the number of moles of sodium hydroxide present in the volume of Fa2 pipetted into the conical flask. So you know how to calculate the number of moles if concentration and volume is given to you. We know that concentration of Fa2 is 0.100 and volume is 0.0250. So this is the result, and you can calculate like this: number of mole, concentration into volume over 1000, because when volume is centimeter cube, so just divide it by 1000 to equalize the unit. So concentration is 0.100 into the 25 centimeter cube divided by 1000. Use your answer to see. So we have moles of sodium hydroxide is 2.50 into 10 raised to minus 3. Use your answer to C1 and equation on page 2. So in this question we use equation which is given above, like this: HA, there is 1:1 ratio. So by using mole ratio, we have moles of sodium hydroxide. So we can calculate the mole of HA. So the moles of HA is 2.50 into 10 raised to minus 3, because there is 1:1 ratio. Use your answer to B and C2 to calculate the number of moles of HA in 1 dm cube. So we know that 1 decimeter cube concentration is equal to mole over volume. We have volume is 0.025 and 2.50 into 10 raised power 2 minus 3 is the moles of HA. So FA1, B and C to calculate the number of moles of FA1. Uh, we know that 2.50 into 10 raised by 2 mole over volume. So the mole over volume is equal to number of moles of HA in 1 dm cube is FA1. Like B and C2. So this is the number of moles and B1. Where is B? And this is B. 25 centimeter cube of the volume of Fa2, because mole ratio is 1:1 and we get the moles of this, and in this volume what will be the moles of HA. So this is so we know that this is Fa1, and you know that 25 centimeter cube. In 25 centimeter cube there are 2.5 into 10 raised per 2 mole volume ratio mole, and in 1000 dm cube ratio x. So this is how to calculate, and this we can calculate like this: 2.50 into 10 raised per 2 minus 3, and this is 0.0250 volume of the Fa1 in 1 dm cube of the A1. So this is 0.100 mole of HA in 1 dm cube of the Fa1 solution. Now use your answer to C1 and the equation on page 2 to determine the number of moles of organic acid used in neutralized 225 centimeter cube of Fa2. Now we have moles, mole ratio. By using mole ratio, C1. This is C1. By using this part, HA and sodium hydroxide, we have the same moles of HA because ratio is 1:1. Using your, this is the same question which I have discussed earlier with you. Okay, 0.1. So now we have 0.100 mole of Fa1 in 1 dm cube solution. Calculate the relative molecular mass MR of the organic acid. We know that number of mole is equal to mass over MR, and MR is gram per dm cube over mole per dm cube. So this is the MR gram, 13.1 gram we have taken earlier in when we start the experiment, divided by mole per dm cube. So this is 0.100, and you know that this is gram per dm cube, and this is mole per dm cube. So dm cube is cancelled out now, left over is gram per mole. So 13.1 over 0.100 is equal to 131. So this is MR of HA is 131. Now studying a student carrying out this method correctly with the same concentration of reactants obtained a titer of 28.30 centimeter. Would this give a large or smaller volume of value of MR than yours? He asked you that same concentration of reactant obtained a titer of 28.30 centimeter. If volume is increased but with the same concentration, would this give a larger or smaller value of MR than yours? So I have 25.15, so the value is 131. When we use uh, increased volume like 28.30 centimeter cube of titer, this would give larger value of MR as concentration is directly proportional to 1 over V, and MR is concentration is inversely proportional to 1 over V, and MR is inversely proportional to 1 over concentration. So 1 over C. So that's why it would give larger value. So there is another question which you have performed in the lab. FB1 is an aqueous solution of 21.50 gram per dm cube of mixture of iron 2 sulfate and iron sulfate and iron 3 sulfate. FB2 is an aqueous solution containing 2 gram per dm cube potassium manganate. In the absence of acid, the iron sulfate is oxidized by potassium manganate. This is the redox equation of this reaction. Now, accordingly, the same method is used. FB1 is fill up according to the method, fill a burette with FB2, and FB2 is the potassium manganate solution. Pipette 25 centimeter cube of FB1 into conical flask, and FB1 is the mixture of iron 2 sulfate and iron 3 sulfate. Use a 25 centimeter cube measuring cylinder to add 10 centimeter cube of dilute sulfuric acid to the flask. Place the uh, to the flask. So acidify the solution with by adding few drops 10 centimeter cube of dilute sulfuric acid to the flask. Place the flask on a white tile because in this solution, because potassium manganate is purple in color and it is taken in the flask, it is taken in the burette. FB2 is burette, that is potassium manganate, and it is placed in the white tile to check the exact color change. Carefully titrate with FB2 until the first permanent pink color is obtained. You should, because iron 2 and mixture of iron 2 and iron 3 are almost solution is light green and light yellow, so almost colorless because this is the dilute solution of iron 2 and iron 3 salts. Your rough titration, like I have discussed earlier in the experiment, you have drawn the table for rough titration accordingly and take rough reading. 26.20 is my supposed reading, and you will use your own titration readings. So this is the same table is drawn for 3 titrations. For 4 you can take 4 or 5 etc. So I have taken 4 reading over here and choose best reading. Best reading of difference 0. Minimum difference is 0.2 centimeter cube between the two titer. So this is there is two same values are there, so I have taken 2 and 4, and my answer of average reading is 26 centimeter cube. Calculation show your working and appropriate significant figures in the final answer to each step of your calculations. Calculate the concentration in mole per dm cube of the potassium manganate in FB2. So this is FB2 contain gram per dm cube. You know that the mole per dm cube is equal to, this is the formula of mole per dm cube to convert gram per dm cube. So mole per dm cube is equal to gram per dm cube over mr of the potassium manganate. So this is how the concentration is gram per dm cube. The gram, this is 2 gram per dm cube. So taking 2 gram divided by 158, 158 is the mr of potassium manganate. So in this way, the concentration of magnesium and potassium manganate is now 0.0127 mole per dm cube. Calculate how many moles of potassium manganate were present in the volume calculated in the B. So concentration is 0.0127 and volume we have taken average reading over here, that is 26. So volume in, convert volume in dm cube because our concentration is mole per dm cube. So equalize the unit, volume is divided by 1000 to get 0.0260 dm cube. So this is the mole, how mole is equal to concentration into volume, 0.0127 into 0.0260. So this is the mole of potassium manganate. Now calculate how many moles of iron 2 sulfate reacted with the potassium manganate. Iron 2 sulfate, mixture of iron we are using in this solution, iron mixture of iron 2 sulfate and iron 3 sulfate. Iron 3 sulfate is already oxidized, so iron 2 sulfate react with potassium manganate because iron 2 is oxidized to iron 3 salts. So this is the reaction by taking mole ratio over here 2 ratio 10, and we have 1 ratio. So to simplify this ratio, 1 is to 1 to 1, the 1 and 5. This is the 1 is to 5 is the simplest ratio. So by using the simplest ratio, 1 ratio 5, 3.3, and this is the mole of potassium manganate. And in this way, I have calculated mole of iron 2 sulfate. So this is the iron 2 sulfate mole, 1.65 into 10 raised per 2 minus 3. Calculate the concentration in mole per dm cube of iron 2 sulfate in FB1. FB1, in FB1, iron 2 sulfate solution is 25 centimeter cube of FB1 is used in conical flask. So we can calculate the uh, mole over volume. So this is mole over volume. So concentration is equal to mole over volume. So 1.65 into 10 raised per 2 minus 3 divided by 0.0250. So 25 centimeter cube is converted into dm cube. So this is the dm cube volume, and mole is 1.65. So the concentration of FeSO4 in FB1 is 0.0660 mole per dm cube. Calculate the concentration in gram per dm cube. By using the same formula which I have used earlier, that gram per dm cube, mole per dm cube is equal to gram per dm cube over mr. So this is the formula to convert gram per dm cube or mole per dm cube into concentration. Like if you have gram per dm cube using this formula, and if you have mole per dm cube and you have to convert gram per dm cube using this formula. So 0.00060 is the mole per dm cube concentration, multiplied by 151.9 is the mr of iron 2 sulfate. So by using this, we have FP1 contain 10 gram per dm cube of iron sulfate is used. So FP1 is an aqueous solution containing 21.50 gram per dm cube of FeSO4 and Fe2SO4 thrice. Calculate the percentage biomass of FeSO4 in this mixture. So the gram per dm cube of iron 2 sulfate is 10 divided by 21.50 into 100. So this is equal to 46.5%. This mixture contained 46.5% iron 2 sulfate. So this is all about of this question.